need for us to incorporate literacy in all of our classes. So that's why we have written response questions on the tests, and that's why we will do some math readings as we go through. Two of the articles that I have, one's from the New York Times. It's called Why Everyone Hates the New Math. Because, you know, whenever you say Common Core, people are like, Common Core. And the other one is Weapons of Math Destruction. So instead of math, it's math. So there's some interesting articles, so I'll see what I can muster up for you guys. But today we're dealing with triangle proportions, or proportions in triangles, but I wanted to condense it down to 2 words. So here are our notes that everyone should have in front of you, but reference up here to the TV. Do you have a question already? No, I was going to try to make it funny. Okay, make it funny.
I was thinking, like, shouldn't it be weapons of math?
Oh, Daffy Duck. Yeah. Did you even know Daffy Duck in the list? Yeah. Your face did not tell me if you understood my reference or not. So, this up on the screen, if you look at the top left, where it relates AD compared to AB, would be equal to the ratio of AE compared to AC. Or AD to DB to AEEC. So whether I take part to whole equal to part to whole, or part to part equal to part, those have to be proportional. So this is actually called the side splitter theorem, because it comes out of parallel lines. It doesn't actually have to come out of triangles, but we use it in triangles to make life easy. So if you can imagine, kind of like this, the corollary to our side splitter theorem, say that 10 times fast, don't do it now. This becomes a triangle eventually, right? If I follow those lines. But I don't need to care that it's actually a triangle. If I have a segment right here, and I compare that to this segment right here, that will be equal to the ratio of this segment compared to that segment. So that's where we get AB compared to BC will be equivalent to the WX to the XY. Likewise, if I threw another parallel line up here, I could compare this segment to this segment, and this segment to that segment, or like I could do green to my middle blue, green. All of these have to be proportional. So that is our side splitter theorem that tells us if we have parallel lines, which when we use it with the triangle, those are the bases of my triangles, but when we have these parallel lines, the segments between them, or the sides that are split, have to be proportional to each other. And we can set that up a couple different ways, like Calvin told us the other day, where if I do, like, compare this to that and that to that, or this to that and that to that, I have a lot of choices with how we set up these proportions. And the other one is just triangle angle bisector theorem. So if CD compared to DB, so CD to DB, AD is your angle bisector. Does that make CD and DB equal? If AD is your angle bisector, does that make CD and DB equal? No. This is a misconception that I want to make sure we're clear on. Angle bisectors do nothing specific with the sides, unless it's a special type of triangle. So if I compare the length of CB to DB, that's actually going to correspond with the ratio of CA to BA. And this is one that people are like, why? Like, why does that happen? And it's because the proportionality that comes from trig. And of course, like, sometimes I wonder if I should teach trig first, but you wouldn't really understand it until we get a lot of these principles down. But because this angle is the same as that angle, the amount of distance this line travels corresponds to the amount of distance this line travels. Likewise, the amount of distance that this line travels out will correspond to the distance it has to travel to get back. So that's why I can set up that this section compared to that will be equivalent, not the same measures, but the ratio would be equivalent to this section compared to, I need like something different. Yeah, like 4 and 3. They're not equal lengths, they're just equivalent ratios. So any questions on our 3 theorems that we're going to be using today? Yeah.
Is there a way to mark proportional?
I might have to look that up. I don't think so, but I don't want to just say no, because I don't know that the answer is actually no. I'm going to make myself a little note. Will you search for it too if you get time, if you're bored? Just look up if there's any like proportional notation, because that's what I'm going to write on a Post-it for me. Proportional notation is what we're curious about. If you can partially focus on the lesson and do so, you can. I think it's going to be a hard search because I don't think there are like notations like congruent notations, that sort of thing. I don't think there's proportional notations, but I'm not certain. So, problem 1, I have pretty much solved out for you up until like the end. We set up our proportion using the side splitter theorem, and your paper prints out in black and white, so I would encourage you to highlight when we do these things if you want it to activate your brain. I do have highlighters if you need. Got blue, yellow, pink, green, all of those at least. I'm going to set these here in case you want them. But when I compare my segment to my segment of the same line, that has to be equivalent to my other segment to my other segment. So one ratio equal to the other ratio. Then I can cross multiply to solve. So now all we have to do is finish out the math to solve this. So when I distribute out this multiplication, what's my left side turn into? 9x plus 9 equal to 12x. Then when I combine my x values, I'm going to end up with 9 is equal to 3x. And then I find out that x is equal to 3. Because solving equations were mainly 7th and 8th grade standards, I'm hoping you guys are okay with me not showing the work between the steps. If you ever wonder how I get between steps, please ask. But I infer that most of you know I combined the 9x with the 12x by subtracting. Then I divided, and I got my x is 3. So then if I plug that in, I see that this segment is 4 compared to this segment of 3. So how does 12 relate to 4 and 9 relate to 3? They're both 3 times. Yeah. So we see that proportional relationship in the split sides. Any questions on how we do that? Now what if, looking at the way that Calvin pushed us the other way, I compare segment to segment this way and segment to segment this way? Does it still work? Yeah. So as long as you have corresponding parts, your ratio will set up equivalent. I don't know why I have 2 smart ink tabs. It's kind of freaking me out. All right, so set up a proportion. Notice I'm not saying the. There's not one right one. Set up a proportion and then solve out for your value of a. Did you find anything on that, Brian?
What? No. I don't could say that.
Well, if it was an easy search, you could probably do it, but it's going to take some time to dig through some websites. Do you guys even know what pogs are?
No, what are they? They're like
Pogs are these little discs that you like play this game with. It was back before
You throw another one on top of them and try to flip them?
Yeah. You have your slammer, which was the heavy plastic one, and then you get them in like cereal boxes. You could buy them. Or you could get them. Look them up.
Alright, so now can I look it up?
Not now. It doesn't have to do with math. You can't look up pogs in math class. All right. What ratio? And there's multiple correct. What ratio did you set up, Caleb?
I said A over A plus 4 is equivalent, or whatever I want to say, to 12 over 18. And I just want to tell you what I solved it up for.
Let's at least do a step. So we see we get
18A equals 12A plus 48.
Yeah, I just want to make sure you distributed that correct. So I combine my A values. We get
6A.
trying to write X when I know it's A. And A comes out to be 8. When I plug that back in, I see that this side is actually 12, 8, 12, and 18. So I see that my ratio there between the segments is actually 2 to 3. Or if I do segment to whole, I can do 2 to 5. So another ratio that we could have actually set up here that I think most of us would probably avoid, but it works totally just as easy. Come on, capture.
Just as easy or just as well?
Well, okay, so easy is a relative word. It is just as effective.
Excuse the interruption. Could I have Caleb Smith to the office? Caleb?
What did I just do? Hey? Yeah, I'm comparing segment to entire length. Segment to entire length. Another proportion that I could set up here would be the a plus 4 over 2a plus 4, and the 18 over the 30, where I do the longer segment compared to the total. So there's 4 main proportions that we could set up, but there's probably more than that too, because every proportion could be manipulated. You got that look? You okay?
I was looking at the next one, but I do have a question that doesn't relate to this, but I'm just
Okay.
going to ask. For geometric means, can you put the variable as the mean or the extreme? Does it matter? Really?
I mean, if you put it as the extremes, you're finding the extreme values, and they wouldn't. I think you can, but in theory, it should come out to be 2 different answers. So I think that is when one would turn positive and one would turn negative. Because when we do the square roots really have 2 answers, a positive and a negative. So let me look into that too. I don't want to give you a strict answer. Did you look it up yet?
No, but like when I was doing the homework, like for ease, like I would always put the variable as the extremes instead of the means.
I think even if you place it in the extremes, you're still going to solve for the mean. That's what I'm wondering, is if it's still, because the multiplication works the same, right? So I think you're still solving for the mean, even if you put it in the wrong location. Let me check into it. I gotta do a few problems before I want to say more about it, and I don't want to say things wrong. So that's a good question. I really like the questions. So we're going camping, and these campsites don't quite seem to be fair. But site C is narrower, longer. Site B is a bit wider, not quite as long. And site A is the widest and not long at all. So we want to figure out the length of site A along the river.
That's why I was making that face. Wouldn't it just be 10 yards?
Yeah, I think I grabbed the picture too late. I need to go back and change that in the notes. But let's solve it to see the justification of it. So if this had started out as X, I grabbed the wrong picture. People make mistakes. I'm a person. So, what? People make mistakes. I'm a person. So 7.2x equals, what's 9 times 8? 72. X comes out to be 10. What'd you say? So although I gave you the value there, that's how we set it up to use in an application. So what now if I want to solve, and actually this might be why I did this picture, solve for this length. How wide is site C? Because like we said at the beginning, it doesn't need to show triangles, it just needs to show related segments. One site will be easier to work with than the other. Well, but you're using a calculator. You want to set this up? So, you want to relate 2 things that are related to each other. So you can either relate site C's length here to one of the other sites' lengths there, and then set that as one ratio equal to one of the other ratios, or relate site C to itself, and then site A to itself. Yeah. Cool. Perfect. So we have a ton of options here. If we call this Z, actually we can just call it C, I guess. We know that we want to solve for C. and I need to relate that to something. I can either relate it to its own corresponding part, or I could relate it to one of the other sites. But if I relate it to one of the other sites, then I'm going to relate this 6.4 here to one of the other sites. So it's up to you which you want to set up. I'm just going to relate C to itself, and then relate A to itself because it's integers. I then get that 10C equals 64 times 9 would be 576. So 57.6, yes? And then we divide by 10 and find out that C is so if you want to get inside my head, it's kind of a scary place. I did 64 times 10, even though it's not 10. So that gives me 640. Then I need to take 64 away from that. So that takes me to 576. But then I knew it wasn't 64, it was 6.4. So I had to bring back in one decimal place. You want to be able to do the math in your head, there's some manipulation that makes it easier. Yeah, I mean, if you can just plug it in the calculator and solve it, but I like to get that mental workout. Ryan?
There's another way you can find that.
Oh, there's tons of ways we can find that.
Other than using the proportions.
Okay, how?
You can do 9 divided by 7.2 to get 1.25, and then 7.2 divided by 1.25.
So you just said you can solve it without using proportions.
Then use proportion.
But that's a
But
proportion.
it's an easier proportion than what that is.
Yeah,
All on calculator.
So you can swim to Hawaii without swimming. You just have to swim.
Yeah, Calvin.
These campsites are really unfair.
I agree. These campsites are really unfair.
Site A gets 90 square yards.
Well, are you calculating using the trapezoid?
Yes.
You have to average the bases. Because do you know these lengths? That's the issue. Yeah, that's the problem. But we could do it as a rectangle and a triangle. And then a rectangle and we could set it up like that.
Cost different things. So
They
you
might.
You pay
Yeah, depending on how much water space you have to pull your boats up or whatever. And these are yards. So that's like 30 feet. Even this, it's like 15, 16, 17 feet probably. So that's fine. Whatever. If you're camping, all is good anyways.
I want to be in site B.
Site
not
C is by trees though, so it would be easier to get fire.
So if a
And
murderer starts
get some raccoons for dinner.
Yeah.
I'm
Yeah,
joking.
you can just sit there and do that. One time the good old sound of people dying.
You're sitting on the chair and just show your
Site
recording
A.
laugh.
And not talk about oh, we're doing this. I kind of wanted to end
Can we bring it back? So my plan is we'll have time for homework because we should be able to move through this quick. So we already solved or got it. So moving on to our problem 3. What is the value of x in this diagram? So now we are relating using the angle bisector. So now this gets set up a little bit more rigid. We want to relate the length on one side to its corresponding or adjacent leg, and then the length on the other side to its corresponding or adjacent leg. So they set up, or how they do it, we can do RQ to QS. So they do it this way. Or we could do it back the other direction, or we could do it up from x to 18 and 12 to 10. So there's 4 main ways we can set up this proportion, because when you cross multiply, they're all actually the same. So these really aren't different proportions, it's just a manipulation of the same proportion. So, if we set it up using the way they told us to, RQ, do you have a question, Ethan? No. So RQ's 10 and PR 12. QS is 18 and PS is X. What's up? Oh, okay. So, give me a second to get there. Cross multiply, we get 10x is equal to 216. You can do 18 times 10 and then add 2 more 18s with it if you want. And we get that x. Ethan? 21.6. Any questions on
How do you say point in Spanish?
punto? Be careful with that. Put an A on the end and it's a completely different word.
That's a good word.
That is a no-no word.
That's a red light word, Mr.
Red
A
light
Hudson.
red light word.
Where did you learn a red light word in Spanish?
All right.
Remember
When you browse the internet enough, you learn
You
learn
know
slurs in every language. Like
There's also books
Yeah.
dedicated to all of the dirty words and languages.
That's what the Urban Dictionary.
We've had to take them away before. Oh yeah, now there's Urban Dictionary. But there, like back when I was in high school, one of my classmates had this French book that was like all the. So, but then they got it taken away because they were saying things in the hallway, and the French teacher was like, "Yeah, I know what you're saying."
Oh, that happened to us. There's a substitute in pedigrees, and they used some French.
Solve this on your own. I mean, you can keep telling your story, but once we solve this, we're done.
They said, I think she said something to Divine, or it might have been Divine or Alpha. And
Oh
they
yeah, and
said,
then Divine.
Divine knows French.
yeah, I know.
And then he says whatever.
He says it out loud.
He says the red light word, and then she's like, "Oh no, 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 no." No, he saw one of her songs.
Oh,
Where
wait.
is that from?
Yeah.
I feel like if I get
Oh, yeah.
Yeah, or like bananas or something like really weird words. De nada. The most important Spanish phrase, if you're ever going to go to Mexico or anywhere like that, is Puedo ir al baño.
What's that?
Where is the bathroom? Or actually, donde está el baño is where's the bathroom. Puedo ir al baño is may I use the restroom. So if you want to be more polite, say Puedo ir al baño, and hopefully they tell you where it is. If they just say sí, señor, you're like, donde está? No, Puedo is like can I, but donde is where. All right. Which proportion, there's 4 to choose from, which proportion did somebody set up? And walk me through the solution. Michelle?
I did 24 over 16 equals y over 9.6. And then that becomes 230.4 equal to 16 y.
Before we move on, and I just released you guys to your homework, is anyone unsure on why this property works? So we're going to start modeling in Geogebra. If you think about the fact that this leg could be extended longer, if I try to keep it straight, then if this point stays in the same place, you're really not cooperating. Then that angle bisector, the angle doesn't change size, but the angle bisector would then come down to here. This length would have gotten longer, this length would have gotten longer, and this length would have gotten slightly longer. So by changing where one of your points is, it extends all those pieces in a proportional manner. Because that angle bisector is telling us this angle and this angle are equal, then when we look at trig and we start setting up like sine and cosine and those sort of values, it'll make more sense where if I change one point or one location or one length, it has kind of a domino effect. So you can't just change what y is. That would then trickle and change 2 other values. It couldn't just change the 16. If I extend this out, it's going to change where the bisector goes and all that sort of stuff. Carmen?
In problem 3, like Dante got it, but yeah. 51. The example, that's what it's called. How do we know what one goes on top and what?
It doesn't matter. So all that matters is that you're relating corresponding pieces. So I could relate 10 to 18, and then I'd have to relate 12 to x because red to blue, these pieces correspond, and these.
Okay.
Or if I relate 10 to 12, I'd be relating 18 to
I
x.
just didn't know how which base went on.
Which actually, so what did we get for x here?
21.6.
21.6. Watch this. What's the change? You're going to remember back to 7th grade math. What's the change percentage-wise between 10 and 12? 20% gain, right? 10% of 18 would be 1.8. 20% of it would be 1.8 times 2. 3.6. I add 3.6 to 18. I get 21.6.
You can solve it easier.
Because proportions are just percents. Proportions are an extension of percent work. Now, that only works easy because we started with 10. But that's another reason why this works. It's just proportional percentage-based relationships. So, I really have 4 ways I can set up any of these proportions. As long as you're relating, like, if I go red on top and then blue on bottom, I got to go red on top, blue on bottom. If I go red to red, I got to go blue to blue. Like, it's just got to stay the same way. Any other questions before I just give you guys the rest of the time? I'm uncertain. Didn't we celebrate it last year? A bunch of black ones? I'll check. We have a birthday sheet.
Oh, you went through the big thing. You go through it.
I have the 7th
The
grade
big
birthday
thing.
sheet, but I don't have
That's
a
what my dad calls it. It was a medical thing.
Maybe we can do
Oh, actually, that happens before 50 these days. Yeah.
Like the day before you turn up. Gotta get ready for that big
My
day
dad
now.
said he